Okay, let's take a look at some exam 4 general questions here. This isn't in your handout. I just added this stuff this morning. But to remember what the constants are, right? You have R and big F and those sorts of things. Now let's get started, Alexa. When do you know a process, and since we're in chemistry, when do you know a chemical process is going to be spontaneous? Yeah, when that delta G is negative. Exactly. Now remember that. That's going to help you out. Okay. When did we use something like this? And in fact, I like the equation better like that. When did we use an equation like that, Victoria? Well, we kind of skipped something. Logically, we kind of skipped something. How do we get delta G0, delta H0, delta S0? Victoria, how do we get all those? Look at the tables. We did what minus what? Products minus reactants. Don't forget about those stoichiometric coefficients. That's how we got delta G0, delta H0, and delta S0. But then they came along with this equation. What did they change? Yeah, they want to know delta G. It's not standard. They're going to pick some temperature. Yeah. Matt remembers. They're going to pick some temperature. And then, what's the delta G at this temperature? And then you had to use that equation. And remember, there was kind of a trick to it. Victoria's right. You use the tables to get delta H0 and delta S0. But what was the bloody trick?
Delta S is in joules.
There he goes. Man, this guy's right on. Delta S is in joules. Delta H is in kilojoules. So remember to convert one or the other. Do everything in kilojoules. Seems to be easier to me. But okay. So that's how we did that one. In delta G0 is negative RT natural log of K. How do you get K? Mariella, how do you get K? Okay, did you hear? Divide the delta G0 by negative RT. Then all that raised to the little e. Now, did she memorize that? Or did the equation tell her to raise to the little e? The equation did, because it's Ln. It's not log. It's Ln. So you raise both sides to the little e at the end. Right. Divide both sides by negative RT, and then raise both sides to the little e. Right. Vanessa, what's big K again? What do we call it? Yeah, what's big K? The what constant? The starts with an E. Equilibrium constant. Big K is the equilibrium constant. Okay. In the equation, delta G0 is negative RT, natural log of that equilibrium constant, Eddie. I don't know. You got to use it for some reason. What R do you use? Why? Do you memorize that? He's right. You used 8.3141. But why? It's in joules. It's in joules. Because the other guy's not in joules. Well, you can use this one or that one. I don't care. But use the one in joules. Just don't use the 0.0826, which is what we've been using all the way up to this point. It's not in joules. Okay. We're here. Where do you get values to plug into the equation E0 cells, E0 cathode minus E0 anode? Nick, where do you get those values? Yeah, and what's a technical word for that table? Standard electrode reduction potentials, right? The standard electrode reduction potentials. Okay. Now, I didn't like that equation, remember? I liked replacing the minus with a plus, because then I don't care what's the cathode, what's the anode. I just use that table. And if I flip a reaction, I do what to the sign on the potential? Flip the sign. It's a lot easier, right? Okay. Do you remember the name of the game, Sylvia? You're given two half reactions. We're still talking about the same equation. You're given two half reactions. How did you know which one to flip? Because the what had to cancel in the first place? The electrons had to cancel. So you have to flip one of those. You find two half reactions in the table. Both of them, the electrons are always on that reactant side. She's right. You got to flip one of them. And it's electrons that got to cancel. So Jasmine, how do you know which one to flip? The one that's smaller. Well, the better word is the one that's most negative. Because they both could be negative. You pick the one that's more negative. Because you want to add those guys up. So E0 cell is the most what you can get it. The most positive. Do you memorize that? No, it's really, where is it? Oh, it's down here. Because we said delta G had to be what to be spontaneous? Negative. Well, that means E0 cell better be positive. We just went full circle. All right, well, that's where we started out. Delta G had to be negative. Okay, so before we're down there, oh, let's just finish this equation. If we're going to use this one, Javier, where do we get that little n? Because we already saw where to get E0 cell, right? The tables, but add them up so you get the most positive. Where do you get the little n? Electrons for the half reactions that cancel out, right? You got to cancel out these electrons to get them to cancel. All right, if 6 of them cancel, well then the total's 6, right? You have 6e minus cancel, right? It's, or 2e minus, 2e minus, right? Whatever you're canceling out, that's what your n is. Okay, let's jump back up to W max. Is that the same little n, Pablo? Yeah, number of electrons that cancel. Same F, E cell, yeah, you know how to calculate it now. You know one way, E cathode plus E anode. What do you call W max? Maximum work is what you're supposed to call. That's what the exams are going to be calling W max, maximum work. Okay, they took away, it could be the one with the little, okay, Vanessa's asking about, let's clear this up here. She's asking about E cell. Is that the same one? Well, it could be or it couldn't. It just depends whether you're standard conditions. If you're at standard conditions, it would be E0 cell. But if you're not at standard conditions, you're going to have to use one of the equations without it. You only have one. All right? We're not down there yet, but you're right. Okay. Oh, where are we? Oh, we're at this one now. Now, Vanessa said, I think it's Vanessa, big K is the equilibrium constant. Jessica, we're looking at that Rojas, we're looking at that little n again. Same thing? Yeah, the number of electrons that cancel in the half reaction. Okay. So, oh man, Bobby, they could use this equation to get equilibrium constant. You got to raise both sides to what to get it? To the, right, if you want to solve for K, so that means they told us little, you find little n, you find E0 cell from the tables, you got to rearrange this to get K. You end up at the very last step, you end up raising both sides to the 10, because it's log, right, to the 10. That would be your last step. Okay. Now, what is the difference? Look at this E cell stuff. It's all over the place. E cell, it's here. It's here. What is the difference between those two? Matt, what's the difference between those two?
Well, in that one, so the top one, you're looking for the constant.
Top one, equilibrium constant. Okay.
And then for the bottom one, well, you could be looking for a number of different things, but the log Q is going to be the products over reactants.
Yeah.
And then when you get that, it depends what they're asking for.
Yeah.
So if they give you E cell, you plug in, well, okay, so you plug in what you know,
yeah,
as Eddie would say. And then whatever's missing, you basically solve for it. Log Q eventually will just take to the 10 of whatever products over reactants.
Okay, let's slow him down. He's right on. There's so many things you could find in this, but several things he said were really helpful, and I hope you caught them. Q is what? Products over reactants. It's the same as what expression? The big K, equilibrium constant. Now, you always leave out what when you're writing those expressions? solids and liquids. Leave those out. And raise things to the, what's the appropriate word? Stoichiometric coefficients. Okay. Now, he's so right, though. You can solve for so many things. This equation right here, that is our chemical sensor equation. Now, that's more than you need to know, but that's what it is, right? Because that Q is products over reactants. Let's say silver ion is in there somewhere. You know the concentrations of everything else. You measure, well, you figure out what little n is from the half reactions, right? The number of electrons that cancel. Again, from the tables, you get E0 cell. You measure this thing. You use a little voltmeter. So you know everything but the concentration of that silver. So these questions, they're really applicable and really powerful, but it's a lot of math to get it. You got to solve for terms inside that logarithm. So there's a lot of rearranging in algebra to get there. So that's a good one to review. Make sure you can do the math. Okay. So he's right. There's a lot of things they could ask for in that type of question. Let's hit a few more points home on that. The little zero's gone, right? Here the little zero's there. Here the little zero's gone. What made it non-standard? Because erase that little zero, that means it's not standard conditions anymore. What changed? What could change that it's not standard conditions?
It gives you the
concentrations. I was hoping someone would say temperature, because I could say, you're wrong, because you got to keep temperature the same, because there's no big T in here. So you can't mess with temperature. It's all concentrations. Standard conditions is where concentrations are always, do you remember? Well, yeah, 25 degrees Celsius, but what's the concentration supposed to be? Just 1 molar. Doesn't really matter. Okay, so you can always use this guy, whether you're at equilibrium or not. Doesn't matter. Any concentrations, who cares? Even if they're 1 molar, just use it. You're always good. Next to the last question, we've got, using the table of standard reduction potentials, which oxidizing agent is better, chromium-3 or tin-2? Now, if you remember these equations, these types of questions, list these chemicals in order of increasing oxidation strength or reduction strength or oxidizing agents to reduce. We had to use the tables. Let's see if we remember how to do this. So we need to find chromium-3's half reaction and tin's half reaction. They're oxidizing agents, so that means they better be getting reduced. Good deal. Okay, so let's find, I'm just going to look it up here quick. So I got my table out. Where the hell is it? Chromium? Oh man, it's way up top. Okay, chromium plus 3. I'm just copying this out from the table of standard reduction potentials. And it's negative 0.74 volts. And I got to find 10. Oh, it is. Okay. 10 plus 2 and 2 electrons. Gives 10 solid. And that is negative 0.14 volts. Now first, I just found these guys, these compounds, and in the half reaction, I scribbled them down. Did I write down the right half reaction, or am I supposed to be flipping these guys to explain this? Because the question is oxidizing agent. Which one's better? So I have to be looking at things getting reduced or things getting oxidized.
Getting reduced.
Things getting reduced because oxidizing agents get reduced. So is my chromium-3 and my tin-2 getting reduced? Yeah. Yeah, right, because chromium plus 3 is going to chromium solid. Yeah, everything's getting reduced. Plus, I copied it right out of the reduction table. Exactly. Okay, so we're supposed to be able to look at these voltages and say which one is a better oxidizing agent. Now remember your guide. Let's clean this up a little bit up here. Your guide is supposed to be this equation. I like having a plus in there. Your guide is supposed to be that equation. I don't know if it is or not, but remember, to find a reaction, you wanted E0 cathode, E0 anode to be the most, and when you find these in these tables, when you add these up, you want to get the most positive number you can get, right? So and when we're doing this, technically, this half reaction or this one, is this E cathode or E anode technically that we're talking about? Cathode, because cathode is reduction. So we're really talking about this guy. It really doesn't matter, right? Because we're talking about the most positive, but that's the advantage of having a plus sign in that equation. We're looking for the most positive number. Technically, it's the cathode. Fine. Right? It looks like we don't have a whole lot to pick from here. They both pretty much suck, don't they? They're both negative, but one is less sucky than the other one. So you'd pick which one's stronger? The tin 2. Because it's only negative 0.14. Right? That would be the stronger one. Okay. The last question is pretty much just the quiz. Know all the symbols and formulas of all those radioactive particles, and I think you'd be set. Okay? So, take a look at these questions. Now, work with the folks around you. The only thing I ask is don't use notes, don't use your book. Ask the folks around you, and if they don't know, just ask me. They'll go a lot faster. I think we'll be more efficient. Okay? So see the folks around you first. I changed the order if you printed these out, because I wanted to do the harder ones first. 10%. Now you remember doing this guy? You write that cell notation. What always had to be on the left-hand side? The cathode. Right. Oh, no, hold it. Things have to be getting more, no, things get more positive. So the left-hand side is the anode, right? Because I'm always imagining, yeah, things getting more positive. Yeah, there's several ways to remember this. One is when you draw these out, the electrons got to flow from the left to right. So the left side's got to be producing electrons. Right side's got to be reacting with them. To produce electrons, you got to be getting oxidized, right? Plus E minus has to be on the product side. So your anode has to be on that left-hand side. That's the that's the convention. That's the convention. Since they tell you what the anode and the cathode are, we don't even have to use the tables. Right? They told us. No, they want the cell notation. Remember, you use a double line for the salt bridge, a vertical line if there's a phase change between the two. An anode has to be on the left-hand side of that salt bridge. For 52? No. Remember, all we did is we wrote that shorthand notation. So, like, it would be 52. What is the anode? The anode is that zinc stuff, right? So you could write, and the half reaction for the anode is going to be what? Zinc solid going to zinc plus 2. Because it has to be an oxidation. So you'd write zinc solid, vertical line, And then zinc plus 2. And you should write its concentration to be... All right. Well, we should write the concentration. What was it? 0.2 molar. And I like writing zinc plus 2 in there better than writing zinc sulfate because it's so much easier to write the half reactions then, if you had to. You can write 0.2 molar zinc sulfate, but then it's not as clear as day that it's zinc plus 2.
We have to add the 2 molar?
You should. You technically, that's what they want in their shorthand notation. All right. Then you need reduction. So what's the iron? Oh, it's iron plus 3, right? Right? Do you agree? And you can write the sulfate in there and the chloride, but I prefer this way. It's easier to write half reactions then. But you don't have to write half reactions. But if there's a part B, I guess. So if you're not sure what to do on any of these, just ask. They're on the assignment schedule. The times and dates. Now. See how to do 84? Anyone see how to get started on it? Oh, no, they don't. They never do. All they want to show is the reactant product. Reactant, product is all they do.
That's how it's always
That's the
set
cell
up.
notation.
And how do you know which one goes on the left?
The two half reactions. Find out what the two half reactions are. You pretty much write them out. And then the one that's getting oxidized is always on the left-hand side.
So the most negative? Or
Would oxidize means getting more positive. This is 0. That one's +2, oxidation state. So that's getting oxidized.
this one's the...
Yeah. All right. You guys see what to do on 84? All right, let's write out. So start, my guide on all these guys, start with the equation. And then it guides you what you need to find. What equation do you think you're going to be using to solve for this one?
No, this is
Well, you need equilibrium constant.
you need K.
Needs one with a K in it.
So it'll probably be the E standard cell.
Yeah.
0.0, yeah, over at
E0 cell equals what?
0.092 divided by N
Log of K. Right? To me, this is your starting point for this question. Right? You should recognize that. And then it really guides you what you need to do. You're after the equilibrium constant. You're after big K. So if these are the two half reactions you're going to have to use, just by looking at them, you should be able to tell what N's going to be. N's got to be 2, exactly. Right? And then the last question is, you got to figure out E0 cell. So that means you got to flip one of these guys because they're both reduction reactions. Okay. Now, usually, you're right, you guys. Usually you flip the one that's, the least positive. But not in this case. You might. I don't know. All I'm saying is they gave you the reaction. So you got to make sure. They want the equilibrium constant for this reaction. So you got to make sure you add up these half reactions and you get that one. So if you flip this one, ouch, you're not going to get the right answer. Because if you flip that one, this chlorate isn't going to be a reactant anymore. It's going to be a product. It's on the wrong side. It's got to be on the reactant side. So don't flip that top one. Flip that bottom one. If you flip the bottom one, then that ClO2 minus becomes a reactant. And that's what you want. So you don't need to flip them and cancel electrons out and stuff. You just got to realize which one to flip. Get your E0 cell, plug it in, plug in your number for N, solve for K. Okay. So if that doesn't make, if it's not clear, just ask. Flip the second one because the second one in the overall reaction, the one that's in black, ClO2 minus has to be a reactant, not a product. So that's why you got to flip it. And you also have to flip it because you got to flip one of them. Otherwise, electrons won't cancel. You usually would flip the 0.17 because then you get the most positive E0. But in this case, they want to know the equilibrium constant not for the most spontaneous reaction. No, they want to know what's the equilibrium constant for that reaction right there, the one in black. So you have to add up the half reactions to get that reaction in black. Otherwise, you're not going to get the right equilibrium constant. So to get that overall reaction, the one in black, that ClO4 minus is a reactant. So you better make sure ClO4 minus is a reactant. That means you better not flip the top half reaction because you'll screw it all up. And then ClO2 minus has to be a reactant. So that means if you look at the second half reaction, if you don't flip it.
Oh, so they give you the one that you want.
Yeah.
Okay.
No, you're right though, Amanda. Sometimes they don't. When they don't give you the one you want to know, then you determine it, and you flip the one that's least positive.
I have a question. Remember how we were doing the half reactions at one time? And let's just say the bottom was to be a 2 and the bottom was to be a 1, and you know how you multiply.
You multiply the top one through by something. You don't mess with the E zeros.
Okay.
Don't mess with those.
Our final is Wednesday after. It's a whole semester. So 3 exams in 1 day. Thank you.
What's the standard?
Well, I know we use potential, so yeah. So is it just the anode conduction?
I think it's about
What Q? It's standard. It's a 25. So you don't need one.
Yeah, but standard conditions, the 25 degrees Celsius is only half of it. The other half is everything needs to be 1 molar, and it's not. So what equation are you going to have to use? The log Q one. Yep. Yeah, don't doubt the problem.
The notation ones, you would want to put this one first and then this one.
It has to follow the half reaction that you just wrote. So this is like a little, that line's like a little arrow. Zinc going to zinc plus 2. Iron's not going to Fe plus 3 because you had to flip that half reaction. It has to be Fe plus 3 going to Fe solid. I'm sorry, this is the one that you're flipping. Yeah, for the cathode.
Yeah, for the cathode.
For this one, it's zinc going to zinc plus 2, so it's that half reaction flipped.
Oh, so I had to flip it.
Yeah, you did, didn't you? We don't have to. They just want the cell notation. So you did zinc going to zinc plus 2.
Well, because I read it just like how it said here, like you have a zinc rod in there.
No. You have to. It has to be following the half reaction. That's going on. An anode is oxidation, so it has to be zinc going to zinc plus 2.
Okay,
So that's why you have zinc on this side and zinc plus 2 over there.
this one has to follow the cathode.
Because it's cathode's reduction.
Okay.
So it has to be a reduction half reaction. Whatever you write has to get reduced. Okay, did you see how to start on 88? What equation are you going to use on 88? The one with the Q in it. Yeah, the E cell. What was it? E0 cell minus 0.0592 over n log of Q. That's the one you're going to use. All right, because it's not standard concentrations. Standard temperature, but not standard concentrations. Okay. Now to get the E0 cell, you got to pick out what the 2 half reactions are going to be. Yeah, find the CrO27 minus half reaction. Find the I minus half reaction.
Yeah, so you're just gonna get.
So find those 2. That's how you're going to get E0 cell. Well, on let's see, which one? Oh, you're doing the top one. Okay, so you found what E0 cell is, and you found what little n's going to be.
Yeah, that's going to be 2.
Okay, now you got to solve for k. So first you do the diagonal thing.
Oh, so the E cell's going to be that one.
E0 cell, you got to solve for k.
Oh, okay.
So bring the n up there with the E0 cell. 0.0592 goes down to the bottom. Then raise both sides to the 10 power, and you'll have it. K has no units. Yeah, it's really a ratio of units, and they're gone. I don't have them. I should look them up, but I would bring your work to the review, and we can check them there. See if you get the same answers as other people. What'd you get? 8.3 times 10 to the negative 7. Oh, okay. Let's write it up there. So you got that too, Pablo, huh?
Yeah.
All right, let's write that up here.
So for Q, do you just add the, well, each, for Q, you know it's products over reactants, right?
Products over reactants.
You add all the concentrations.
So write the expression. Products over reactants, raising the stoichiometric powers.
Liquids and solids don't go.
I know. The only ones it gives you are all aqueous, regardless.
And don't forget the stoichiometric coefficients. So it has like
Yeah, you lost me.
You see how it has that 2 CR? It's to the single power. Yeah.
Okay. So we've got an answer for 84. A couple folks got 8.3 times 10 to the negative 7. Good deal. Anybody get an answer for 88? How did you find the two half reactions you got to use to get E0 cell?
How do you know which one to flip again? Like, you say, like...
Okay, so this is, which one are you doing? You're doing, okay. Oh, you have to follow that, because they gave us the reaction.
Okay, and that's what I
So
wrote
you
down.
have to have CO207 has to be on the reactant side.
Yes, you have it all
So
written out.
definitely don't, so definitely don't flip this one. Otherwise that'll get screwed up. Now, yeah, you got it, because I minus needs to be on the reactant side.
And this is 6, and this one's 14, minus 2 is 12. And
Well,
then
you
I
don't,
said it's-
really, you don't, if you look at what you're after,
You're just looking for the E?
you're just looking for the little E0 cell and the little N.
Okay.
Because they already gave you the overall
So
reaction.
And I already know it's going to be 6.
You already know it's going to be, little N's going to be 6.
And then the E cell, but I would have to flip the bottom one, right?
You're going to flip the bottom one, so flip its E0 number. You don't multiply by 6 or anything.
Add 'em, and
Then add 'em
E
up.
cell, and then
Yeah. Yeah.
For this, when you split it up into half fractions, you do it the iodine too, but you go off of what's here.
Yeah, so you're going to find out that
I got
you're
this
going
one right here.
to flip the iodide half reaction. Right? So you're going to flip its E0 and add that to the CR027. Right? Because you really don't need to add it all up, because they gave you the overall reaction. You don't need to go through all that.
So you just need to flip one of them.
You just need to flip that iodide. So you're after that little n. Now, folks are getting 6 for the little n. Hopefully you're getting 6 for that little n. Okay. Hopefully you're getting 6 for that. And then when your E0 cell should be, what are you guys getting for that? 1.33 plus, and a negative 0.79. Thank you. So you're doing this right. If you figured out that your little n's got to be 6, your E0 cell's got to be 0.79 volts, and they did that by picking out the right half reactions on the table. E cathode plus E anode. And then they substitute in the concentrations. You got to substitute in the concentrations in your Q expression, and you'll have it. Did anybody get an answer for this? 0.63? Yep.
How did you get 6 if
Okay.
I cross out that and that?
Well, you'd have to multiply this one through by 3, and you did. So this would be 6, and 6, they would, so 6 electrons are what's canceling. That's why you multiplied this one through by 3 in the first place.
Oh, well, what if
So this is really
there's-
3 I2s and 6 and 6.
So, okay.
You don't multiply that one by 2 because you already got 6.
No, I'm saying, what if it was an example like this?
Then you have to multiply this one through by
3
3 and that one through by 2.
So how much?
So n would be 6
Mm-hmm.
because 6 is what's canceling.
Only
How do you
because you
think it's
multiply it?
Well, it's
Six up
because
here and
whatever
about
the
6
total
right
is, whatever you're
the
canceling
total
out.
electrons
I'm canceling
is.
6 here, and with 6 there, I'm canceling 6. She dug up the 2 half reactions. That's how you got to find them. And I suppose we should have flipped this one.
I flipped the answer.
Oh, okay, that's good enough, right? Because we really don't care about getting the overall. This is the important part to flip. Yep. We don't really care about the overall reaction because they gave it to us. We got a couple more minutes. Did anybody get an answer for 88? You got point what? 0.76? Anybody else get an answer? 0.63? I got 0.63 also. So I bet you 0.63 is right. So come to as many of these reviews as you can make, right? You can bring your work here that you've wrapping up these questions. You can check them out.
So it would be this one. Oh, it has the moles up there. My bad.
Well, they gave you all the concentrations, and they gave you the overall reactions. Just use it. So it has to be products over reactants. So like you see, Cr plus 3. Right, I'd write the expression. It has to be Cr plus 3 in brackets, raised to the second. Don't put iodine in there because that's a solid, and don't put water in there because that's a liquid.
Oh, I got it.
Right. And then do the same for the denominator over the reactants. F10, right, big guy?